Hello, everyone. Welcome to the latest edition of Accolite Digital Connect, our thought leadership series that focuses on the latest technology trends and business insights featuring some of our experts. Today, we are back with the third and final session in our three-part series on machine learning. In today's session, we will look at how machine learning models are picking up human biases through our data and what is it that we can do to minimize them. We will also take a look at the different ways in which we can improve the machine learning model's performance to get much better results. And like the previous two sessions, I'm happy to introduce our speaker, Priyanka Pal-Shetkar, who is a product manager at Accolite Digital. With an experience as a full stack developer and a data analyst in investment banking and the finance domain, Priyanka is also the co-founder of Alma, which supports the entrepreneurial aspirations of Indian homemakers through technology. And of course, she has also been recognized as a Harvard's Crossroads Emerging Leader and Hindustan Times Pune's Top 30 Under 30 for 2019. Before I hand it over to her, if you have any questions, please put them in the comment section below so that we can take it up at the end of the session. So without further ado, I'll hand it over to our speaker from here. Welcome to the session, Priyanka, and over to you.
Thank you, Swati, for the introduction. Hello, everyone. Good morning, good afternoon, and good evening. I am Priyanka, and I want to welcome you all to Accolite Digital Connect again. Today's session is the final one of this three-part series that covers the most important aspects of machine learning. In this series, we focused on building a fundamental understanding of machine learning and its capabilities. So in our first session, we looked at what is machine learning and what are the different types of machine learning algorithms. In the second session, we deep dived into the simplest machine learning algorithm, that is linear regression, and understood the basics of training a machine learning model. But in today's session, we are going to focus our attention on what do we mean by machine learning biases and what are these biases telling us about ourselves. So I have divided the agenda for today into 4 parts. First, we will understand what do we mean by biases in machine learning, like this classic example which I shared last time, which is an example of gender bias in assuming that a doctor will always be a man, which is still present in the Google Translate model, by the way. Then we will take a look at why should we even care about machine learning biases. Third, we will try to understand the different types of machine learning biases. And finally, we will look at different ways in which we can try to reduce these biases. With that, let's get started. So what do we mean by a machine learning bias? Now, if we try to define it, bias is the prejudice or unreasonable unfairness that creeps into our machine learning algorithms, which results in discrimination and other dangerous social consequences. Now, let me give you a simple example to clarify this definition. So imagine that I wanted to create an algorithm that decides whether an application gets accepted into a university or not. And one of the inputs to this algorithm was geographical location. Now, usually the location of an individual is highly correlated with their ethnicity. So, for example, since I live in India, then my ethnic background is Asian. Now, in an ideal world, for getting accepted into any university, ethnicity should not be a relevant or a deciding factor, right? However, a biased machine learning model would indirectly favor people from certain ethnic backgrounds more over other people, even though I have not given it any ethnicity data explicitly. So this is an example of bias in machine learning, and we'll take a look at more such biases. So now that we know what we mean by a machine learning bias, our obvious next question would be, okay, so what? Like already we are working hard enough to build this machine learning model, and now you want us to account for these biases as well. Why should we even care about these biases? Take my word for it. We should care because machine learning is everywhere. It is present in all systems around us. And if these systems are biased, then so are the results. It isn't difficult to see that if we biased algorithms to solve real world problems for us, then that can have consequences and sometimes even unintended ones. Now, whether we like it or not, the impact of machine learning on our life is growing very rapidly. Machine learning algorithms determine whether we would get the mortgage for our dream home and also if our resume would be shortlisted for the next job or not. In the world around us, robots are taking over warehouses and factories. Self driving cars are threatening to disrupt the jobs of millions of drivers around the world. And even our legal systems are increasingly using machine learning to screen for potential criminal leads. And all these decisions that the machines are aiding affect each and every one of us directly. And hence, it's evident that this is something that we definitely need to be mindful about and we should care. Okay, now that we care and we want to work towards reducing these biases, we first need to understand the different types of machine learning biases that exist. This will in turn help us identify them in case our models start producing biased results and even enable us to decide on any preventive action that we could take to reduce them. So let's take a look at these different types of machine learning biases. The first one being prejudicial bias. Now, these biases make their way into a machine learning model because the people who are designing them carry these biases unknowingly. Now, over the ages, we as a society have developed deep rooted prejudices that are difficult to do away with. And this can influence any stage of developing a machine learning model. Hence, this is perhaps the most complex and most difficult to manage source of a machine learning bias. Now, one example of a prejudicial bias is of a 2015 study, which showed that in a Google Images search for CEO, just 11% of the search results had women in them, even though 27% of the CEOs in the US are female. That's a prejudicial bias because when we think about a CEO of a company, our first instinct is to think of a man, unknowingly, but yes. And that gets reflected in our data as well, which the machine picks up when we train it. Now, the second type of bias is sampling bias. We know that data is the core of any machine learning model. And how we collect this data to train our model can also lead to bias being introduced in our machine learning models. Now, a sampling bias results from an error in the early stages of development of our machine learning model. That is, when we are gathering and cleaning the data. When training the model, if the developer chooses a wrong sample data set, maybe one that is small in size or contains many faulty data points or doesn't represent the entire distribution well, then the results will be inaccurate for all the data points that differ from this sample. After all, the algorithm can't learn what it didn't see, right? And an example of sampling bias would be Siri not able to understand people with different accents. Why is this? This is because it was never trained on samples that included different dialects and accents. Now, an important step in the development of any machine learning model is choosing the algorithm, and that brings in a third kind of bias, which is algorithmic bias. Now, algorithmic bias is the error that occurs when the algorithm at the core of the machine learning process is faulty or inappropriate for the current application. Now, as we have previously seen, there are several algorithms to choose from, like linear regression, random forest, decision trees, SVMs, and many more. Although these algorithms have many applications, there are certain use cases that fit a particular algorithm better. And if we make a wrong choice, that can lead to a bias in predictions. Now, an early example of algorithmic bias resulted in as many as 60 women and ethnic minorities being denied entry to St. George's Hospital Medical School from 1982 to 1986. The decision was based on the implementation of a new computer guidance assessment system that denied entry to women and men with foreign sounding names based on historical trends in admissions. Now, while many schools at the time employed similar biases in their selection process, St. George was most notable for automating the said bias through the use of an algorithm, thus gaining the attention of people on a much wider scale. And that is an example of an algorithmic bias. The next kind of bias that we will talk about is confirmation bias. Now, once we start training our model and evaluating its predictions, we may tend to retain information that confirms our preconceived beliefs. So, in confirmation bias, we end up excluding or removing data or results that go against our theory in the process. This will lead to a certain bias in the data and therefore our model's predictions. Now, while this may satisfy us as developers, it can significantly reduce our model's usability and impact its results. Now, confirmation bias is particularly evident in applications of machine learning where human review is required before any action is taken, like maybe in healthcare. The use of machine learning in healthcare has seen doctors to be particularly dismissive of algorithmic diagnosis because it doesn't match their own understanding. Often, when investigated, it turns out that the doctors haven't read the most recent research machine might have, and hence this points to slightly different symptoms, techniques, or diagnosis outcomes, which doctors are not ready to accept. So that's an example of a confirmation bias. Another type of machine learning bias is historical bias. Now, while gathering data for training a machine learning algorithm, grabbing historical data is almost like the easiest place to start. We can just go into our company systems and grab data which is like years and years old. But this leads to introduction of historical bias. And if we are not careful, it's very easy to include bias that was present in the historical data into our models. Now, take Amazon for example. In 2014, they set out to build a system for automatically screening job applicants. The idea was just to feed the system hundreds of CVs and have the top candidates picked out automatically by the algorithm. Now, the system was trained on 10 years worth of job applications and their outcomes. So, what was the problem here? The problem was that most employees at Amazon were male, particularly in the technical roles. The algorithm learned that because there were more men than women at Amazon, men were more suitable candidates, especially for tech roles, and actively discriminated against non male applications. This is a classic example of bias caused by using historical data. By 2015, obviously, the whole project was scrapped by Amazon. I hope now we understand the different types of biases that can creep into our machine learning models. Obviously, this is not an exhaustive list, but these 5 biases represent the most important ones and help us get a near complete picture. There are many more biases that exist, but let's look at how we can reduce some of these biases now. So, okay, now we know the different types of biases that can creep into machine learning models. So let's try to address them and reduce them. As we saw earlier, machine learning is essentially a heuristic process. Now, what do we mean by that? So for most practical applications, we treat machine learning as this black box where data enters in one end and predictions flow out from the other. And although we can explain all this to a certain extent, we don't completely understand what is happening inside. And this also makes checking and eliminating biases a little cumbersome. Now, despite all this, it is certainly important that we work towards reducing these biases because they impact us directly. So let's take a look at what we can do towards that. Now, one obvious solution is to use the data that should be and not what is. And by that, what I mean is, it is natural that the randomly sampled data that we have will have bias, because we live in a biased world where equal opportunity is still a dream. The current performance of any machine learning model is only as good as its training data. We have to proactively ensure that the training data we feed into our model is comprehensive, it is balanced, it replicates real world scenarios, and it represents everyone equally in a way that does not discriminate against a particular group of people. And a good rule of thumb for ensuring this is to try and not to reuse data sets. Like, by that, what I mean is, data from an area with an ethnically diverse population, like maybe India, cannot be applied to a region with predominantly a single race, like maybe America, and vice versa. Or with Amazon's hiring algorithm, had there been an equal amount of data for men and women, then the algorithm may not have discriminated as much. So, our data plays a very big role in reducing the biases, because if we give the model unbiased data, the model is going to give us unbiased results. So, we have to actively work towards giving the model that unbiased data for training. Okay. Now, choosing the correct machine learning model is another logical step towards reducing machine learning biases. Now, we know that there are primarily two types of machine learning algorithms, which we have looked at, which was supervised and unsupervised. Now, in a supervised model, the training data is controlled entirely by us, by the stakeholders who prepare the data. So we can ensure that this group of people who choose the data are chosen equitably and provide them training on unconscious bias. So if in this we would provide unbiased data to a supervised machine learning model, then we can reduce its bias. On the other hand, an unsupervised model depends on the algorithm itself to detect bias trends. So we need to factor in bias reduction techniques so that our model learns to distinguish between what's biased and what isn't. And we'll take a look at the tools which can help us incorporate those bias reduction techniques now. Now, as responsible businesses, we should also work on our debiasing strategies. Now, these could include developing a three-pronged strategy. First is our technological strategy that involves using tools that can help us identify potential sources of bias and reveal the traits in the data that affects the performance of our model. Now, one such tool is Google's What If tool. This interactive open source tool allows a user to investigate machine learning models visually. Its bias detecting feature and algorithmic fairness analysis can discover patterns that were previously not identifiable. Another tool is IBM's AI Fairness 360. This open source toolkit by IBM helps mitigate bias from massive data sets, as it is developed on more than 70 fairness metrics and 10 bias mitigation algorithms. And then there's Microsoft's FairLearn tool, which is also open source, and it allows data scientists to detect and correct the fairness of their machine learning systems. Now, I want you to notice two things about these tools. First is, all of them are open source. And second, they are developed by three of the biggest tech companies in the world. This particularly emphasizes the importance of the mission of removing biases from our systems, because biases impact us so much that we need to talk about how we can reduce them. Now, the second prong in our debiasing strategy is our operational strategy, which includes improving our data collection processes. For this, we can use third-party auditors, and even have dedicated teams for validating the reliability and correct the biasness of the data we collect. And the third prong is our organizational strategy. This includes establishing a workplace where metrics and processes are kept transparent. So, we should also work on bringing more diversity and inclusion in our organization. And that's not just for the sake of having diversity and inclusion, because people that first notice bias issues are mostly from that specific community. Therefore, maintaining a diverse team can help you mitigate unwanted biases in our machine learning models, because it's most likely that someone from your team will definitely point it out to you, and then you can work towards it and remove that bias. So that's a very good strategy towards building an organizational aspect of reducing the machine learning biases. And lastly, the solution is not necessarily to change the model, because machine learning just captures the world as it is. It just happens that our world is full of chaos and bias. Changing the way the algorithm works would make it less effective. Withholding data might also not work because our models learn from data. And even if we don't tell the model if someone is a man or a woman, you are going to provide it some information that is correlated to gender, and the model will probably figure it out. So you cannot avoid those things. Instead, we humans can work on the other end to correct the mistakes that machine learning makes. We should provide methods to monitor and continuously review the models as they perform in operation. If there are signs that certain forms of biases are showing up in the results, then the organization can take action before the bias causes irreparable harm. For example, if Google Translate's performance can be tweaked to improve its translation. So if you see that a doctor is always translated to a he, while a nurse is always translated to a she, you can suggest that change. That's it for today's session. I do want to leave you all with one thought though. Now, there is a bigger philosophical and ethical question that comes into picture with the kind of results our machine learning algorithms are presenting in front of us. And that is how flawed we are as humans. Because these biases are not machine created biases, these are inherited in our world. And the machines are showing us a mirror and giving out a loud and clear message that it is high time for us to change and take collective action against our biases. So that's it for this series. Machine learning has a lot to cover. In fact, each slide in this presentation could be a separate topic. However, I hope I have helped you gain some basic understanding into the most important aspects of machine learning and its capabilities. So thank you so much again for being here. If you have been throughout the first two sessions as well. And over to you, Swati, if you have any questions.
Sure. Thanks, Priyanka. That was indeed a very, very insightful session and food for thought, to be honest. I mean, it actually reflects the kind of world that we live in. So yeah, if we want machine learning models to be free of biases, I think that's something that it has to come from us. So yeah, but we do have a few questions that have come in. So we spoke about how machine learning models are picking up biases and also the ways to mitigate that. But, the first question is that will our machine learning models ever be completely free of biases?
So technically, if I talk about it, the answer is yes, because a machine learning model is as good as the quality of input data that it gets. So if we do give it a clean training data set, which is, it doesn't have any conscious or unconscious assumptions on race, gender, or any of those weird things, then we should be able to build a machine learning model that makes unbiased data driven decisions. However, in our real world, our models cannot be completely unbiased. It's because obviously, like, models can be as good as the data that they get. it's like what I mentioned previously, right? And we humans are the ones who create that data. So since we are flawed and we have the biases, sometimes we don't even realize that they exist. And since it's not possible to have a completely human being, then how can we expect that our machine learning models will be completely unbiased? So it's as that saying goes, as master as pupil, that kind of thing. But obviously that doesn't mean that we should not try to eliminate as many biases as we can. Removing biases is definitely a never ending process, because if you think about it, we might not know what is even considered as a bias, because what is okay today could be tomorrow's bias. Even what is a bias in India could be not a bias in some other country, depending on cultural context. So there are a lot of factors and contextual features that come into way, which makes this a very never ending process. But this is exactly why we should constantly strive towards removing these biases, because it would help us, build better models which give us build better results. And that's why we have machine learning models, to ease and automate and make our processes faster. So we should work towards that, reducing biases from our models and our own selves. And I hope we do get to a point where we are also as unbiased as possible, and so are our models.
Right, yeah, absolutely. That does make a lot of sense. So the second question that we have is also on very similar lines, that, we humans have biases, right? And if we talk about unconscious biases, then sometimes we have biases whether without even knowing whether we have any. So how can we remove these biases from our ML models when we ourselves are so biased?
So exactly, we cannot. The question answers itself, because obviously we cannot, because we you need to know about something to do something about it. But we can certainly learn, right? Like I said, machines are learning what is out there, so they cannot learn what doesn't exist, which means biases are present with or without machine learning. But our machine learning models, what are they doing? They are helping us catch these biases faster. They're like presenting a mirror to us, telling us that, okay, look, humans, you are biased. And usually we wouldn't realize that we are being biased. So when I say nurse, most of us would still think of a woman. That comes naturally to us, right? But taking the effort to change that once we identify it as a bias is important. Now, our models can show us a clearer picture about our world, of course. And it is certainly a better scenario for us, because previously, like you said, we didn't even know about that we were biased. But now we do. And we can work on our shortcomings once we know what they are. And you are right when you say, like, how are we as a biased society even qualified to fix the biases in our models? But my counter to that would be, if not us, then who will do it? Certainly not the machines, right? So we need to take it one step at a time, even if that step is as small as not assuming a nurse to be a woman. So that would be my take on it.
Great, great. I think that really explains it well. So these are the questions that we have for now. In case any of you have any further questions, please add them in the comments section and we'll be happy to address them later. But before we conclude the session, thank you, Priyanka, for sharing all those insights. And thanks to all our viewers who tuned in for this session. And we really look forward to having you join us for yet another interesting topic in our next edition. Thank you so much.
Thank you.